All right, welcome back to Sports Betting Truths, Intro to Power Rating series. This is the fifth and final video of the series. We got a lot to cover today. This is what it's all been building to. A lot of new concepts will be introduced today, so stay tuned. This is going to be excellent. So without any more wasting time, let's jump right in. So the thing we are covering today is a NFL multi-factor power rating system. In the first four videos, we only focused on one or two stats, but today we're going to just throw a bunch of stats in there and see what happens, and learn how to create power ratings based on stats that don't directly relate to winning or scoring. For example, I went to Football Reference and just picked a bunch of stats that I thought might make sense for a football power rating system. I didn't spend a lot of time picking and choosing the stats. I just picked stats that might look good, like offensive yards per play, defensive yards per play, percentage of possessions ending in turnovers, and the opponent, plays per first down, aka how many plays does each team run until they get a first down. Net yards per pass attempt, it's a stat that measures passing yards per attempt. Offensive and defensive yards per rush, percentage of drives ending in scoring, sacks and time sacked, and then the average field position of a starting drive, and same for the opponent, and the opposite stats for each. Now if you watch video number 3, you would have seen the whole concept of this database tab and how it's modular. All I had to do is just add these rows, and that's it, to this corresponding columns right here on the raws column. So in the first 4 videos, we only had these 4 columns, but I had to add these extra columns for all of our new stats. Now I didn't do game-by-game stats on the scores like I did for the wins and scores. What I did is I just went to Pro Football Reference and copy and pasted the table and just did a VLOOKUP from there. For example, here's the yards per play, I think defense stat right here. So I just did a VLOOKUP and put it in the corresponding column. So for the Patriots, as you can see, 4.7 matches the 4.7. So that's what I did for all the stats this way. But as you can see, here's the raw grid. Now I added one column in the database tab, and that's a per game. So are we calculating these stats out of the raws tab in a per game basis? The points, yes, because it's a sum, but pretty much all the stats apart from sacks are already average, so we don't need to divide them by game. But sacks are a sum, so we do want to divide those by games. As you can see, everything is no except yes, yes, and yes, yes for points, 4 points allowed, and sacks, which we then translate onto the raws per game tab. This is everything on an average basis, whether it be per game for these stats right here, or just an overall average for the season. Now, in order to get this tab from this tab, I did have to create a new macro, and it's simply called raw per game calculate. So it simply loops through the database and gets the columns and gets the stats, and then it does an if statement. If per game equals yes, then divide the stat by number of games, print on the raw tab, otherwise just print the stat. And then we do the same thing with the league average in home advantage, and then we calculate the home advantages with a new loop through the database. So when I run the raw per game calculate, which is right here, it does all that, and here we go. And when we go to the league tab, all the per games are calculated there, and here are all the advantages. Now, not all of these teams have an advantage. Like home teams in 2019 had a more likely percent chance for a possession to end in a turnover than the away team, as you can see. However, it required less plays to get a first down. The net yards per passing attempt were higher for home teams. Yards per rush was higher. But scoring drives, away teams actually had more percentage of their drives end in scoring. And away teams were more likely to sack the quarterback than home teams. So it's not always an advantage. That's why you would hypothetically do this over multiple seasons to iron that out. And actually, away teams had a slightly better, very slightly better starting field position. So here's all our new raw stats and averages, right? So now we want to adjust them. So all we need to do is let's do 5 rounds of adjustments. But I created a new macro called new rating cycle, which subs raw calculate with raw PG calculate. That's it. So go ahead and assign this macro to raw PG calculate, and let's adjust 5 times. So here is our adjusted final tab, which has all the adjusted stats on here. So when we go to the ADJ analysis, what I did is I just calculated the differential between raw and the final adjustment round. As you can see, the plays per first down, not much change. The Browns required less plays on an adjustment basis, minus 0.11, which is pretty low compared to like the turnovers, 2.05. Scoring drive percentage, 4.8 for the Browns. But just because the numbers are higher in this column versus like the plays per first drive column doesn't mean the overall effect of the change is different. What you would do to measure that, let's zoom out a little bit, is let's do like a standard deviation calculation. So to do a standard deviation calculation equals stdev.p, and then let's drag all of our numbers right here. So the standard deviation is only 0.03. And the standard deviation for, say, the scoring drive percentage, we can just copy and paste this right here, is 0.98. So when you measure in terms of how big of a change relative to the standard deviation, for example, the Browns equals abs I6 slash this number right here, we have a 2.92 standard deviation change for the Browns just by decreasing 0.11. But on the flip side, 4.8, that's the biggest number on that column as well. So you would do equals 0.06 divided by this number right here, a standard deviation change of about 4.87, still higher. So there's still more fluctuation here, but just because the numbers are smaller in this adjusted column versus this one doesn't mean the impact is smaller. All right, so now the question is, now what? How do we incorporate all of this into a power rating, right? Well, here's where regression analysis comes into play. Now, hypothetically, we could incorporate all these stats into a power rating. You could do that, and it might not be a bad idea to do that. But how about we use a regression to pick which stats are the best and then go from there? We don't want to use all these. Maybe we do, but let's go ahead and do a regression analysis based on these stats. Now, the thing with Excel is that you're limited to only 16 X values in a regression. So I had to divide up these schedules into different halves that have 16 sets of stats each, right? Hypothetically, you use software that lets you do more, but this is Excel. Anyway, go to data analysis, and we're going to go to regression. And margin is going to be our Y range, and our X range is going to be all this right here. Make sure labels is checked, and then hit OK. So here's our regression analysis. So the R-square is 0.37. That's not terrible for box score stats. All these stats that are used for this are used out of a box score, by the way. It's not drive level data. It's not play-by-play level data. So what we're going to do is we're going to look at the p-value. So I'm going to color these just so we can see them easier. So the lower ones are in green, and that's what we want. So we're going to select the lowest values. So points per first down, there's a good value right there. That's pretty much close to 0. And then it looks like net passing yards is also somewhat low. So we can go ahead and use that. So we're going to use net passing yards and plays per first down. We're going to advance that to the next round of our regression out of this regression cycle. So that stat and that stat. And so let's do the same thing for the next wave of stats as well. We're going to do a regression right here. You can go ahead and get rid of that. So we're going to do a regression on this tab as well. Same thing. Regression, and hit OK. All the columns are the same. So let's go ahead and color our p-values again. Lower is better. Okay, so scoring drive percentage looks good. And that's probably about it. I guess you could use sacks, but like I said, since we're limited to 16 and we're already going to use the PA and PF stat, let's go ahead and just take scoring drive percentage out of here. Now we're going to do a regression based on that. So the stats that we picked from those two were plays per first down, net yards per passing attempt, and scoring drive percentage. And now all we need to do is a VLOOKUP. So we got 9, 10, 9, 10. I'm putting the column values from here and here so I can drag the VLOOKUP over. So net yards per passing attempt is 11 and 12. And then scoring drive, I think, is 15 and 16. So according to our regression, the turnovers and the field position and all that didn't have low enough p-values to advance to the round of 16. So these are these stats that have the lowest p-values. We already know the PF and PA are going to have low p-values, so those already advanced. So what we're going to do here is a VLOOKUP, and we can just copy and paste this. See how I have VLOOKUP B3, so that, the table from ADJ final, and this number right here in false. And then I can just copy and paste them over and down. So now we have the table filled. We're going to do a regression based on this. And here we go. So we were able to improve the R-squared to 0.4. Remember, the others are like 0.37. So it might not seem like that big of a jump, but it is. And remember, we're using box score stats. Box score stats are not going to be as predictive in terms of R-squared and everything as drive level stats or play-by-play level stats. So that's actually a pretty good number for box score stats, 0.4. So now we can look at the p-values and determine which of these stats are the most predictive. Of course, like I predicted, the PF and PA are the lowest, but then the offensive plays per first down, also pretty low, and then the rest not so much. So let's keep this tab saved for weighting purposes later on. All right, so now we have our stats that we're picking. How do we incorporate all this into a total offensive rating, defensive rating, and total rating? Well, first let's go ahead and fill in our stats, 11 and 12 and 15 and 16. And now we can just do a VLOOKUP. Select this team right here, put a $ in front of the A, comma, table, ADJ final. We can select the whole table. Don't forget the $ in front of the letters and numbers, so we can drag it. And then we can go back to this tab and select this number right here and put a $ in front of the 2 and then false. And then we can just drag this over, get it all filled in, and then we can format and then down. Okay, so now what? We have all that filled in, so now we need to normalize everything. We could create an offensive rating of just the averages of these 4 numbers, but like they're not equal. Like a 39.4, that's measuring percentage of offensive drives that ended in a score. But this is measuring offensive net yards per passing attempts. They're not the same number, so you can't average them. So how do you average these 4 numbers to where all the numbers are equal? Well, you have to normalize it. I use normalizing in all my models, so I'm teaching you something right here that I do in everything I do. So I'm going to zoom out a bit, and as you can see right here at the bottom, I have 2 additional rows, the league average. So I'm going to go ahead and copy over the league average for our various stats. All right, so we have our league averages in, and now we just need to calculate the standard deviation for all the teams, which is pretty easy. It's equals stdev.p, parentheses, and just drag this number right here. So the standard deviation for offensive plays per first down is 0.02. You know what, let's go ahead and give an extra decimal. And then I can just copy and paste this over. And here's our standard deviations for all of our stats. Very important. So to normalize, what we do is subtract each team's stat from the league average and then divide it by the standard deviation. That's how you normalize. So for the Packers, we'd take their points for, so parentheses B4 minus the league average, so B $36 divided by the standard deviation, so B $37. So the Packers normalized points for stat is 0.22. So basically what this number says is the Stackers point for stat is 0.22 standard deviations above the league average. So what we're doing is calculating all these stats as how many standard deviations above or below the league average the stats are, and that way everything is apples to apples. So now I'm going to copy and paste these over. So as you can see, I skipped these 2 columns, and here's why. Because in this column, this column, and this column, those 3 offensive columns, a positive number is good and a negative number is bad, but it's the opposite for these 2 columns. In these 2 columns, a negative number is good for offense and a positive number is good for defense. So we just need to flip things a little bit. So we're going to do the calculation as normal, so equals double parentheses D4 minus D $36 divided by D $37. 0.16. So the Packers are above the league average. So what we're going to do is just take that number times -1 and just change it to the inverse and then drag down. And there we go. So now the Ravens were -1.71 and now they're positive 1.71. So we can just do the same thing over here, format paint, and there we go. So the Patriots have the best defense and now their number is negative, right? So now we can do an average of the 4 equals average this number, this number, this number, this number, and now we have an offensive rating. So the Packers' offensive rating is 0.09. Remember, positive, good, negative, bad for offense, and then we can drag it down. So the highest offensive rating, the Ravens, 1.98, and the Chiefs, 1.92. The worst is the Redskins at -1.27, the Bears -1.24. So that's the offensive rating. So now we can do the same thing. Defensive rating equals average. This number, this number, this number, this number. Negative is good, positive is bad. So the Patriots have the best defense, -1.28. Ooh, look at here though, or -2.15. And then the 49ers, -1.76, also had a good defense. So the total rating, obviously, is the offensive rating minus the defensive rating equals the total rating. So the highest total rating was the 49ers at 3.06, followed by the Ravens, 2.78, and the Chiefs at 2.41. But that's assuming everything has an equal weight. As you can see, I have the weights column right here, which allows us to weight things. So if we were to run a regression, there's 2 ways we can do it. Our margin is going to be our Y value, and our X range. Let's do this first. Let's just do the total rating for each team, just an away and home rating. Okay, so our R-square is 0.373, unweighted. So let's try this. Let's do the same thing. Margin is still our Y range, but instead of the total rating, let's do these four over here, the away offense, away defense, and vice versa. So when we do it that way, the R-square goes from 0.373 to 0.378. So it was a slight improvement if we used the offense-defense breakout instead of the total. So let's go ahead and get rid of that. So now that we know that using the offense-defense breakout is better in terms of a regression. So the R-square is lower than when we use all the stats that we included, but remember this is a early power rating and it's an R-square of 0.378 with only really one stat, and that's the combined power rating. So yes, the R-square is lower, but we're just at the ground floor right now. So when you remember this, the PF and PA was the best set in terms of p-values, followed by the plays for first down, and then the net yards per passing attempt and scoring drive percentage a little bit worse. So let's go ahead and add some weights to our stats. So let's do this. Let's make points for and points allowed 0.4 and points per first down 0.35, and then this will be 0.125. So everything equals 1, so all of our weights we want to equal 1. So PFPA is getting about 40%, plays per first down about 35%, and everything else about an eighth. So did anything change? Well, the Ravens overtook the 49ers for the top spot in the total rating. So let's run a regression and see if these weights make our calculations better in terms of regression and R-squared. So that remains the Y value and the X range remains that. So the weights brought our R-squared up to 0.38. So a slight improvement, but it was still an improvement, which shows that weighting was the right idea. So what if we wanted to make predictions based off this? Well, here we go. Take the intercept and coefficient. Now, if you notice, the intercept is usually the home advantage and things like this. And remember, it was really non-existent, so at least in 2019. So the intercept being low makes sense. So if we're doing a prediction, remember week 1, the Ravens beat the Dolphins 59-10. Let's see what this model would predict if they were to play again in the same circumstance. So we would do equals intercept, which is D7 plus parentheses the away offensive rating, which is D3, times the away offensive rating coefficient, which is D8, and then E3 defensive away rating times the away defensive rating coefficient, which is D9, and then just down the line, D4 times D10 plus E4 times D11. So we could expect the Ravens this time to win by only 26 as opposed to 49 the first time around. What if we wanted to calculate score instead of margin? Well, we're going to come back over here and do the same thing, only we're going to change the Y range to away score, and the input X range will stay the same. So now we have a new set of coefficients. We can put it right here. So we're going to call this margin. This will be A score, and this will be H score. So equals intercept, which is E7 plus D3 times E8 plus E3 times E9 plus D4 times E10 plus E4 times E11. So we expect the Ravens to only score 41.5 this time against the Dolphins as opposed to 59. And then we would do another regression for the home score. Just change that, and here's our new coefficients. So equals F7 plus away offensive rating, so D3 times F8 plus E3 times F9 plus D4 times F10 plus E4 times F11. So 41-15 this time instead of 59-10. And just to do a checksum, equals J3 minus J4. Does the score margin equal this margin? Yes, it does. So our models check out. So let's do another one. Let's do the Kansas City Chiefs and the Dallas Cowboys. We could expect the Chiefs to win by 33-24 by about 8.68. So what if you wanted to do win percentage? Well, what we could do is we could go back to the 4th video of the series and take the offensive and defensive ratings and come up with a Pythagorean expectation calculation and exponent based on the method we use in video 4, and then plug that into a log 5 equation. I'm not going to do that for this video though, just to keep it short. Just go back to video 4 if you want to see how to do that. You could also do a logistic regression. Now these types of regressions I do here are linear regressions, and as far as I'm concerned, Excel doesn't have like a logistic regression function here in the data analysis, so you do have to use a third-party software like R or Python or Orange to do a logistic regression, but you could easily take the same data right here, and the only thing you'd do is you'd add a new column called win. So let's do that real quick. Win. D3 equals E3. Remember they're ties. 0.5. Otherwise, if D3 greater than E3, 1, 0. So if the away team won, it gets a 1. So I'm going to go ahead and copy and paste this into a new Excel file, and I'm going to call it Logistic. And then I'm going to open up my Orange program, which is like a free data software that you can use, which you can use for things like logistic regression. I'm going to go new, and I'm going to do model logistic regression. And then I'm going to do data file, and I'm going to select our logistic file. Our target is going to be the win, and then we're going to skip these. We're going to skip that. We're going to do meta. We're going to skip the margin. Skip the home score and away score as well. So we really want our feature variables to be we'll go ahead and skip the total rating too. We really want our feature variables to be the 4, and then our win to be the target. And then I guess we can do meta for away home. Then we're going to drag a line to the logistic regression. It's giving us an error. Yeah, what you want to do is you want to set the win to be categorical and not numeric, because the logistic regression, what it's doing is saying either or. A team either wins or a team either loses. There's no in between like margin that's linear. Logistic is a categorical regression. So that's why I had to change the win to categorical. So here's our coefficients right here if we wanted to plug these in for a logistic regression, but there's an easier way to output things, and that's to do the predictions. So go to predictions and drag this right here. Whoops. And then we're going to create a different file, and it's going to be the same one, logistic. Now we can open these and we can see the predictions. So here's the number we're looking for right here. Obviously the Packers, let's find that Ravens and Dolphins, right? So obviously it says the Ravens are going to get a 1, right? But it gives the Ravens about a 90% chance of winning. That's what this number is right here. It gives the Dolphins an 8% chance and then a 2% chance of a tie. It's pretty much what these numbers right here mean. Packers, 64% chance of winning, 1% chance of the tie, 35% chance to lose. So that's what those numbers mean right there. So this is how you do like mass predictions in terms of win percentage using a logistic regression with our stats using Orange. But with all this, the sky is the limit. This is just very basic examples. Remember, this video series is an intro to power rating. It's not in-depth advanced power ratings. So the point of these videos is to teach you concepts, teach you ideas and ways to approach things. But like I said, I just picked random stats. Like I took like 1 or 2 minutes just to find these random stats to use for this video. But ideally you would test multiple stats and try to find new combinations of stats and everything, and not just limit yourself to 16 stats that you can regress on Excel, but use other software for regression to use an infinite amount of coefficients and inputs to come up with the ultimate model and get those R squared values higher and higher. This is just to get you started. This is just the ground floor. I taught you how to adjust. I taught you how to do regression, and I taught you how to do Pythagorean and exponent finding. And now in this video, I taught you how to weight your stats and come up with normalized power ratings and use logistic regression with Orange and all of that. This is just the ground floor. This is just the tip of the iceberg. And that's why this video is about an intro to power ratings. So you learn a lot of concepts here. So I hope this can get you started, not just with the NFL, but with any sport. The principles of adjusting and Pythagorean exponents and logistic regressions and all that are the same across all sports. You just got to find the best combination of stats and weights to use for a model that you can use to predict. But that wraps it up for this series, Intro to Power Ratings. 5 good videos that I think will be very helpful. As far as the next series I'm going to do, I have a series planned, which is going to be how to use R for sports analysis, but I just don't know when I'm going to be able to start that. Not because I'm not ready or don't have time, but I just want to make sure I get everything down, because I don't want to just put out videos just for the sake of putting them out. I want to make sure it's good. And if I'm going to make a video tutorial series on how to use R to analyze sports, I want to make sure I got it down pat. So I might take a little bit of time to come up with that one, so it might not come out anytime soon. So until then, I'll just probably go back to my normal videos about betting in general. But stay tuned, a lot more coming out of Sports Betting Truth, but I hope you really enjoyed this. Well, until next time, this is Sports Betting Truth signing off.